look at absolute value equations. Take a look at the equation that's on the board. The absolute value of x equals 5. In reality, there are two numbers that will make this true. I'm going to call them two cases. In case 1, the number that's inside the absolute value sign could equal 5. Case 2, the number that's inside the absolute value sign could equal -5, because the absolute value of -5 is also 5. So this one has two answers, 5 and -5. Absolute value equations typically have two answers. Let's take a look at this example. It's absolute value, so there are going to be two cases. In case 1, the value that's inside the absolute value sign could equal 4. In the second case, the value that's inside the absolute value sign could equal -4. We have two equations to solve. Subtract 2 from both sides, and we get two different answers. Y is 2, or y is -6. Either one of these numbers results in an answer of 4 when we take their absolute value. Take a look at the third example. It's tempting to go ahead and write the two cases, which we've learned to do, but look closer. It says that when I take the absolute value, I get -1. We know that absolute value is never negative. It's either 0 or a positive number. So there is no way that I'm going to be able to take the absolute value of something and get -1. So this equation has no solution. Let's take a look at these graphs and see if I can write an equation. Notice that there is a dot on -4 and a dot on 4. So that absolute value equation would be the absolute value of x must be 4. This one is not so obvious. There's a dot on 1 and 5. They're not opposite numbers of each other. But let's see if we can find the number that's midway between them. That would be 3. Do you see that they are each 2 units away from 3? So we would say their difference of 3 from the number equals 2, because they are no more than 2 units away from that difference of 3. Finally, let's graph absolute value equations. To graph an absolute value equation, we need to find where the absolute value would be 0. In this one, where does x minus 3 equal 0? Well, if x is 3, this would equal 0. This tells me how to make my table. I'm going to put in 3 for x. And then I'm going to put in some numbers on either side. 2, 1, 4, and 5. Notice I put 3 in the middle. All right, if x is 1, 1 minus 3 is -2, but that absolute value is 2. If x is 2, 2 minus 3 is -1, but the absolute value becomes +1. 3 minus 3 is, of course, 0, and that's absolute value is 0. 4 minus 3 is 1, the absolute value is 1. Do you see a pattern? 5 minus 3 is 2, and the absolute value is 2. Do you see how the patterns repeat for the positive and negative number? When I go to graph it, I'll graph 1, 2, 2, 1, 3, 0, 4, 1, 5, 2. Absolute value graphs make a V. And where is the point of the V? The point is where the value equals 0. Let's take a look at this one. First of all, we have to find where the absolute value would equal 0. So x plus 2 would equal 0 when x equals -2. I'll make my table knowing that. I'll put -2 in the middle and some numbers on either side. How about -1, 0, and -3, and -4? All right, let's plug in our numbers and see what we get. The absolute value of 0 plus 2 is 2. 2 plus 3 is 5. The absolute value of negative 1 plus 2 is 1. Absolute value of 1 plus 3 is 4. Negative 2 plus 2 is 0, and 0 plus 3 is 3. Negative 3 plus 2 is negative 1. Take the absolute value, you'll get 1. 1 plus 3 is 4. The absolute value of negative 4 plus 2 is negative 2. Absolute value of negative 2 is 2. 2 plus 3 is 5. Do you see how, once again, it's symmetric around this value where it is 0? Let's graph it. 0, 5, negative 1, 4, negative 2, 3, negative 3, 4. Whoops, it should be negative 2, 3, negative 3, 4, and negative 4, 5. It makes a V once again. And this is the point, the vertex, where the value is 0.